Hello everyone, this is just a quick addendum to the previous video in which we were examining Huygens' principle. So, the very last idea that was supposed to go in that video is that Huygens' principle can be used to explain reflection and refraction as well, and is the origin of Snell's law. Okay, and to see this, we're just going to take a quick look at a GIF that demonstrates how Huygens' principle can be used. So if you examine this GIF, you can see that several wavefronts are shown. So let's examine the blue ones first. The two wavefronts that are depicted in order to show how the outgoing wavefront is going to be at the same angle as the incoming wavefront. So theta I equals theta R for the law of reflection. You'll notice that instead of showing all of Huygens' principle's semicircles, so instead of showing the outward propagation of the wave via point sources on every point along the wavefront, we just use the two endpoints, okay? And then we connect them to see where that wavefront is. So when the green dot hits at that first location, you'll see that the reflected point source, boom, propagates outwards, and then boom, a second one, and you can see how that outwardly propagating wavefront continues forward. And you can analyze the geometry of that if you would like to prove that they are at the same angle. Notice that you can do the same for refraction, and notice that in the second medium, right, the speed is slowed, which means that the whole wavefront is going to be bent because that red outward propagating wavefront does not travel as fast as the blue one. So if we wait for the left side, boom, the red one starts and it's slow and it's slow and it's slow, but the other one's fast and boom. Now that second point hits and you can see that the outward propagating wavefront in the slower medium is traveling slower. And in fact, you could measure exactly how much, dependent on that speed, using geometry. So you could prove that Snell's law applies. But you can see that Huygens' principle can explain this wave behavior.